Okay, questions 3A to 3C for what chapter are we in? Chapter 3 for an introduction to statistical learning. So this is a three-part question. Okay, so here's the question here. So we have a set of predictor variables, GPA, IQ, level of education, which is a binary variable for either having graduated college or, I guess, not graduating college. It's not really clear what that means, but I'll just assume that that's what it means. As well as two interactions, one between GPA and IQ and another one between GPA and level of education. Okay. A regression, and the response variable is starting salary after graduating in thousands of dollars. And so a regression is ran, presumably, on this data set, and we get the following coefficients here. Okay. For B1, B2, etc., correspond to X1, X2, and the B0 or B0 is like the intercept. It's 50, or it is the intercept, an intercept. Okay, so question A is which of the following answers is correct? And so we're asked to go through these different statements and say which is correct. Okay, so all of them are assuming a fixed value for IQ and GPA. Okay. And we're really comparing high school graduates versus college graduates in each of these. So let me go down here. So here's the answer that I put in there. So the way that we want to do this is we have fixed GPA and fixed IQ for people. Okay, and so we want to say does a college graduate or a high school graduate make more? Okay. And so the way that we do this is we can just go and start filling in values. So the idea is that this value and this value, GPA and IQ, are going to be the same in the two comparisons. And the thing that's going to change is education level. It's going to be 1 for the college graduate and 0 for the non-college graduate. Okay. So if we look at the terms, the first one we come to is 35 times. So that's the beta coefficient 35 times education level. So this, if I just stop there, that would mean that college graduates make $35,000 more as a starting salary than non-college graduates. Sorry. But if I continue, I notice that education level has a interaction here with GPA, and it's -10. So in other words, a college graduate. So if the person has graduated college, then this would be 1, right? And so then this term would be 1 times 10 times GPA. A high school graduate or a non-college graduate, this would be 0, so this whole term would be 0. And we see that this is negative. So that means that the higher the GPA for somebody who's graduated college reduces their earnings upon graduation. And so there would be scenarios where a high enough GPA would reduce earnings below that of a non-college graduate. Now we can quibble about, okay, has this regression made appropriate assumptions or not? I think possibly it has not. If for no other reason than GPA in college is much different than the GPA in high school, I would assume. But anyway, but that would be possible. So it's possible then that a college graduate makes less than a high school graduate given the same IQ and GPA. Okay. Now, question 3 basically specifies that. It says for a fixed IQ and GPA, high school graduates earn more on average than college graduates, provided that the GPA is high enough. Well, that's the situation that I just described, and so I'm not really sure how 1 and 3 differ, because I think that if you think all the way through 1, you arrive at the same conclusion as you would for 3. So it could be that question 1 does not want you to consider the interaction, but I don't see, there's nothing in the question to indicate that that's the case. So 1 and 3 are answered. Okay, so 3 true, C 1. Okay, and then for possibility 2, for a fixed IQ and GPA, college graduates earn more on average than high school graduates. Okay, so again, if I run through that same thought exercise, well, that is possibly true given that the GPA of the college-educated person or college-graduated person is not beyond some threshold, right? So anyway, so possibility 4, it is for fixed IQ and GPA, college graduates earn more than high school graduates provided that the GPA is high enough. So this one is false, and so to get to that reasoning, you just need to look at 1 and 2, because if the GPA gets high enough for the college grad, then we already said that the education level, or that the earning starts to go down. Now, if they would have said if it is low enough, then I would say that that statement is true, but they say high enough. Okay. Next, we need to predict the salary of a college graduate with an IQ of 110 and GPA of 4.0, and so we just simply plug those values here into this, and so if I've done my arithmetic right, then I should get this. Okay. $137,000, $137,100. Okay. Finally, true or false? Since the coefficient for GPA IQ, so let's locate that before moving on. Interaction GPA and IQ is x4, so beta 4 right there. Okay. Where are we at? Since that interaction term between GPA and IQ is very small, there is little evidence of an interaction effect between these two variables. Justify your answer. So this might be a small value, although small is a relative term, especially if we're thinking about IQ. So 100 IQ points, well, all of a sudden, you multiply something by 100, and now it maybe starts to become important. And then you multiply that by 2, 3, or 4 for GPA, it might become a very big number. But even that misses the point. The size of the estimate is not indicative of the strength of the evidence. The strength of the evidence would be encapsulated in the p-value for that beta coefficient, not in the size of the beta coefficient, and we're not given the p-values. So C here is false.